Hello and welcome to the final module of this course. In the previous modules, we explored spatial data, spatial temporal data, and artificial intelligence. Now, in this concluding part, we bring these ideas together and look at pattern recognition in movement data. Movement data often contain repetitive or characteristic patterns, whether it's predicting the path of hurricanes, analyzing tactics in team sports, or identifying typical user behavior for mobile services. Detecting such patterns requires suitable methods, ranging from clustering and sequence mining to approaches for analyzing group movement. In this module, we will first focus on the definition of movement patterns, and afterwards we will look at different methods or approaches to recognize those patterns. By the end of this module, you will understand how movement patterns can be detected in movement data and how those methods can be applied in different real-world scenarios. Have fun with this last module, and I hope you get many valuable takeaways for your future work.
Okay, let's get started with the content of this final module. When looking at movement data, one of the most interesting but also challenging questions is, do we find patterns in it? So we are looking for repetitive structures, let's call it movement patterns, which help us to understand behavior, make predictions, and maybe in the end develop smart applications. In this first part, we will look at some motivating scenarios to see why pattern recognition in movement data matters. The first scenario is about the automated choice for mobile services for smartphone users. Like shown here on these diagrams, you know nearly everybody is using smartphones, is using applications offered on the smartphones, and we want to find out which of those mobile services or location-based services are relevant for the user at a certain point in time. So the problem here is that we have a massive demand or excessive demand by a lot of services, and the question is which of those services is helpful for the user at the current time. And on the other side, which information is used to select those services. One approach dealing with this problem is that we select the mobile services based on the user's intention. The question here again is, what is the user's intention? Maybe we can derive the intention from typical movements or typical behaviors, which are somehow encoded in our movement patterns we want to find. Looking at the images below, here we see three different scenarios. So one user in the image on the left, one user is heading straight from one location shown here to the station. Yeah, this is the station here. And you can see this is a very straight line. So you see, okay, there is no really zigzag or so. So maybe in this case, I would interpret it that he is in a hurry to catch the next train. If you compare this to the second scenario, in the second image here, it's the same path, the same route. However, here you don't see any straight lines. So maybe the speed is not that high, and maybe in this case the user's intention is not to get the next train, but maybe he wants to have a look at nearby shopping windows or other interesting points of interest. Here you can see really the zigzag movement, which is somehow showing that, okay, maybe here the user is not that fast. So maybe in this case, the user's intention is different as well. Maybe here it was shopping. On the other hand, on the image before, it was maybe the station, so the leaving train. In the last example on the right, you can see, okay, there's somehow a different movement in a different place. However, he maybe starts at a location, then he does a turn, and he nearly ends at the same location. Here it's quite hard to understand why he's doing something like that, but maybe, yeah, either he's doing some sports, running around the block, or maybe he's looking for something and he does not find what he's looking for. In this case, maybe you do not offer something like the last train or nearby shopping offers, but maybe in this case you find, or you provide either some sports applications to track yourself, or maybe you give the next route or directions to the nearby hotspots like points of interest or so. Here we have a totally different scenario, which is coming from the sports domain. In particular, it's football. You might know this guy on top right. So he's Arjen Robben, former player of Bayern Munich and Real Madrid and other teams. He was very successful, although he was in the wrong teams, but still very good player. And the special about him is he always he was very famous for a certain move. He has a so-called signature move, the Robben move. And looking at Wikipedia, there's an extra article for him, and which was called the style of play, because he, as I said, he has a signature move. He was always doing the same, but still very successful. And here's this, I highlighted a small description what he actually did, but maybe I can also show you on the next slide. So you have to know that Arjen Robben is a right-wing player. He's a very fast right-wing player in this case. And he typically moves in this area of the field, right? So which means he usually gets the ball, or typically gets the ball somewhere in this location here, and then he starts running along the line. But somewhere there's usually a sudden change of his direction towards the middle of the field. Yeah, and this was quite hard to defend by the defenders because he's a quite fast player, as I said. So which means he just runs towards the middle, and as soon as he has a good angle and there's nothing between him and the goal, he shoots at the goal. And often he was quite successful in this. So, and this does not happen once a game, this happens multiple times a game. There's also nice YouTube compilations showing all his goals, which are somehow looking the same, because this was his typical Robben movement, right? So then that was quite interesting. And here we can see, okay, this could be also kind of pattern, which we might identify if we are looking at football later. Yet another different scenario is coming from the meteorology, which means we are looking at the hurricane data, so hurricane movements. Here on the left part of the image, you can see this is the trajectories of the storms over a certain period of time. And what you can see is that they are somehow similar, right? And the idea could be that if we know the typical movement again, so typical movement in this case could be also kind of movement patterns, the movement patterns of a storm. If we know the pattern, then we might also predict where it will go. And this, of course, is very important for the people living in the coast of US or Central America or wherever it will go. So in all three examples before, we were looking for movement patterns or typical movements, typical behavior, like the storms, the football player, and the smartphone users here. But still, we have to somehow define what a movement pattern is. In this case, so in this course, we will define it as repetitive, a priori unknown movement patterns, like given here. So in repetitive patterns means, or repetitive movements means, for maybe we can look at this trajectory given here. So you can see, okay, there's some parts of the trajectory which are somehow repeating, which are highlighted in blue here. So in these parts are somehow similar. In this case, they're the same. Yeah? And the problem is that we unfortunately do not know how these patterns could look like in the beginning, right? So they're a priori unknown. So we are looking of any pattern or any movement which is somehow repeating. So in this case, it repeats 3 times here. And it can be in one trajectory, but it can also be distributed over several trajectories of the same user, but also over different users as well. So in general, those patterns we are looking for may contain some information which could be useful for different use cases. Yeah? One use case might be the prediction. One use case is the characterization of an object. The prediction is quite straightforward, I would say. So maybe if we observed several patterns, here in this case, we might have 2 patterns, so the gray one and the blue one. So the blue one is this U-shaped movement, and the other one is a more or less straight movement, the gray ones. And now if we observe an object which is somehow following the blue trajectories, so in this point in time we want to know, okay, will it go straight or will it turn left like the blue ones? And as it follows obviously the blue ones, the chance is quite high that it also will follow the blue ones in future. So we might predict the future locations of this place. So in this case, he might turn left as well. On the other side, for the characterization of the objects, we might also have observed several patterns here again, the blue and the gray ones, and we observed that the blue one is always used by object A, the gray one is always used by object B, and now we have not identified, so an unknown object, but we can still observe its movement, and then we can compare the movement to the collected patterns and maybe somehow infer the identity of the object. So in this case, for example, it looks similar to the blue ones. So here we might get a hint that this unknown object was also object A, or at least object of type A. Yeah, so maybe this was the same object. So recognizing patterns in movement data could be seen as two different tasks. It's on the one hand, it's pattern matching, and on the other hand, it's pattern mining. So pattern matching is more like if you already know the shape of the pattern, maybe you have a kind of zigzag movement, and you want to identify the zigzag movement in the data set. Yeah? So you just compare, so you want to match this particular pattern to the trajectories you collected, and you want to identify all those occurrences which are looking the same or similar. On the other hand, when doing pattern mining, we do not know these patterns. We do not know the shape of the pattern. But still, we want to find the repetitive occurrences of these patterns. So it's a little bit more complex in this case. And in the remaining part of this lecture, we want to focus on exactly this task, the pattern mining task. So in addition, when looking for those patterns in data, and looking for the occurrences of the pattern, so we can define, or we want to define, that one movement pattern consists of different instances of this pattern, so the different reoccurrences of the same pattern or same movement or similar movement within the trajectory data. So here, for example, we have again our trajectory, and here this one movement pattern consists of 3 instances given by these parts of the trajectory. So together, those 3 instances together is just one movement pattern. And here we can also define some requirements. So the first one is there should be somehow a minimum support or support count. And on the other hand, there should be a minimum length of the pattern. The support count means how often this, or how many instances should appear in the data set. And the minimum length is rather obvious. So we want to define how long this trajectory part should be. This is important because you might find structures like, for example, those small straight lines here very often in this data set. So you will identify a lot of patterns, but the information gain of such a small pattern is comparably low. So we might not looking for something like this, but maybe for more sophisticated, more advanced patterns, which of course contain much more information which you can use for identification or prediction. So here we can easily transfer this into our previous example of Arjen Robben and his signature move. So here you see the highlighted same movement during one game. Of course, this is artificial movement. I've drawn this by myself, but maybe it looks the same on real trajectory data. Here you can see, okay, this were the 3 instances during the match. So his 3 moves, which are somehow similar. You always see this hook-like structure. And now these 3 instances are treated as one movement pattern, right? So you see 3 instances is one movement. Okay, with this idea of movement patterns and all these definitions, we now can have a look at the data where we want to find those patterns. So here I just provided 3 different data sets from different domains. Yeah, we have the football data on the top left. Yeah, you see, okay, there's a bunch of trajectories of football players on the field. Then on the top right, you see, okay, there's a traffic data set. Actually, it's the bus lines in Chicago. And the last one is the monkeys, which are tracked, or the group of monkeys. In particular, it was baboons, which were tracked over a period of time or longer period of time. And what you can nicely see here, it's not that easy to identify those patterns by just having a look at the data, right? Maybe it could be possible for the bus lines, but not for the football players and not for the monkeys. Yeah, so and that's why we want to talk on the next part of the course. We want to talk about different approaches, how we can get the patterns out of this data, so how to recognize those patterns, and yeah.